Okay. Yo, what's going on, everybody? Hey, Sylvia, what's going on? Welcome in. Thanks so much for coming in today. Let's go ahead and wrap up our chapter 5. All right, cool. Okay. Nice. All right, cool. We're ready to go here. Thanks so much for everybody for coming in today. My name is Michael. Welcome back to the channel. Hope you're having a wonderful day so far. Today we're going to be jumping back into C programming, a modern approach. Today we're going to be jumping back into C programming, a modern approach, 2nd edition. This is going to be chapter 5, the back half of the programming projects from the end of the chapter, number 8, 9, 10, and 11 more specifically. We'll probably finish these up and then move on to chapter 6, and then maybe play some League of Legends tonight. So, feels like a good night to get a little stream going, get some studying going, and play some games and have a good time. So, welcome everybody for coming in. I appreciate you guys being here. So, we're going to take a look at number 8 here. Okay, the following table shows the daily flights from one city to another with these departure and arrival times, kind of like a hash. Write a program that asks the user to enter time expressed in hours and minutes using the 24-hour clock. The program then displays the departure and arrival times for the flight whose departure time is closest to that entered by the user. Okay, cool, let's try this. So let's include the standard io.h header file. And let's do an int main, int main void. And what we're going to do is take a printf function, and we're going to ask the user to enter a 24-hour time. And then we're going to call scanf, and we're going to do closest departure time is, and then we're going to, oh, oops, sorry. We're just going to receive in that the time that they're wanting, right? Which would be like this, and then we're going to save this in hour, and we'll save this in minutes. We have int hours and minutes. Okay, so now what we're going to do is convert the time. So int time in minutes is equal to, we'll have this be an expression of our hours times 60, right? Plus the minutes, right? So that'll give us our total time in minutes. And then what we can do is these times, right? So if time in minutes is less than we haven't really learned about other functions yet, like writing other functions. So I would write like a function to do this conversion, but if time is less than so this is going to be 8 times 60, right, plus 0. So this one's going to be for 8 a.m. So if the time is less than this, you would do the flight at 8 a.m., right? So then you would do, so I want to say int departure and arrival. Oh, well, we don't actually have... We don't have that char stars yet either, shoot. So let's just do this. So if the time in minutes is greater than 8 a.m., which 8 times 60 plus 0, what we're going to do is we're going to do the printf, take closest, departure time is 12:47, sorry, is 8 a.m. Arriving at 10:16 a.m. Right? Okay, then we'll copy this down and say else if time in minutes is less than, so if it's less than 8 a.m., we go here. If it's so if it's less than 9:43 a.m., so this one's going to be 9:43 a.m. Right, you go to 9:43 a.m. arriving at 11:52. Write a program that asks the user to enter time expressed in hours and minutes using the 24-hour clock. The program then displays the departure and arrival times for the flight each departure is closest to that entered by the user. So then I'm going to use a break statement here. Well, I'm going to ask, hold on, if else if chain in C, like Python, will not read the else if, or is it not like elif? C does read the else if, just like Python reads elif. The only difference is syntax, not behavior. In Python, elif is a keyword. In C, there is no elif keyword. You literally write else if, but logically they have the same context. Only the first true condition is executed, but C does not check later. else if blocks once a true has been executed. Okay, so we actually don't need the break. So the else if, this will satisfy and stop. So then let's go, whoops. Let's go ahead and copy this one down. So if the time is less than 11:19, so say 11:19, right, this is going to be 11:19 to 1:31, right? And then if we copy this one down, 12:47, okay, and then 12:47, it comes in at 3 p.m. Are they always the same distance, 2 hours and 16 minutes apart? No, 2 hours and 8, sometimes, okay. This is at 12:47 to 3 p.m. And this goes to 12:47 p.m. Okay, next else if is going to be for 2 p.m. Uh, 2 p.m. So this will be 2, right? So this is 14. Right, and then plus 0. This will be between 2 p.m. and 4:08 p.m. Okay, and then we have 3:45. This is kind of a lot, geez. Time in minutes. This goes to 15. This goes to 45 minutes on the tail to be added in. This would be 45 to 5:55. Okay. Now let's keep going down. This will be 7 p.m. So 7 is, oh shoot. So it's what, just 7 plus 12? So it'd just be 18. And this is 0, 0. Okay. And then this is 7 p.m. to 9:20 p.m. And then we have one last else. No, we don't want to do else because you're gonna miss your flight. I mean, so 9:45, 21. $45. Hey Tim, how's it going, dude? 9:45, arriving at 11:58 p.m. Okay, now we're gonna go print F. Oh no, wait, we already are doing print S. So actually I need to add just some \ns here. Can't wait till we get to next chapter. We learn looping. We get to looping, so it'll be a lot way better for us. 2 p.m. 2 p.m. p.m. here. Okay. Okay, let's see here. Let's try it out. Okay, we're gonna go CD, chapter 5, programming project. CD chapter 5. Okay, let's go ahead and grab this guy. We're gonna do number 8. Oh. Okay. Okay, 24-hour time. Let's enter 7 a.m. Closest departure time is 8 a.m., arriving at 10:16 a.m. Perfect. Let's do 13:15. Closest departure time is 2 p.m., arriving at 3 p.m. Or 8 p.m., so no. So 13:15 is actually 1 o'clock. So our math is wrong. We're supposed to do that. Gave us the 2 o'clock one here. So 12 o'clock and 13 is 1 o'clock, 14 is 2 o'clock. We do this. Printf. Time in minutes. Let's do this. And let's get that out so we can see what it prints out. Am I being dumb? Yo, what's up, Gabriel? Appreciate you for coming in. Welcome in today. Let me make this a little bit smaller and make this a little bit bigger here, and I can zoom in here. Let's scroll this over. There we go. Okay, so we've got some issues going on here. So this is going 13 times 60 plus minutes, which is less than this, 2 o'clock. So 1 o'clock is 13. Wait, hold on. Entered 24-hour time, 13:15. The closest departure time is 12:47 p.m. Oh, even if you go over. So I think our logic is slightly different than what the problem is asking. Convert the input to time expressed in minutes. Which is 795 minutes. Which is closer to this time than any of the other departure times. So we have to just find the closest one, like absolutely, right? Not like without going over. Oh, that sucks. Actually, I did that wrong then here. So if you that's kind of stupid. Why would I want us to do that? I don't know. So we have to find the minimum, right? We have to find is it closer to this time or this time, basically. Okay, so let's back up here. Okay, so if the time in minutes so we basically have to find which one to do. Okay, so if the 8 a.m., so we have to do this. If the 8 a.m., right? If the 8 a.m. less than the time in minutes is greater than right, so if is greater than 9 times 60 plus 43, right? No. Less than the time in minutes, right? Then you display this one. Okay, right? So if the time in minutes for the 8 o'clock value minus the time to departure is greater than, no, we want to do the closest time is less than, right? So if this is closer than this one, then you'll do this. So now what we can do is take this, come down, go else if, and make this the 9:45 or 43. Now we might be able to get away with something a little bit easier here. Let's try this. Let's do int int 8 a.m. 9:43 8:00 a.m. 9:43 a.m. 11:19 a.m. 12 47 p.m. 2:00 p.m. 3:45 p.m. 3:45 p.m. 7:00 p.m. 9:45 p.m. Okay, this might seem kind of crazy, but just bear with me. So rather than doing this math here, we'll just compute it out front. Right? Why don't we just compute it out front here? For these values. Oop. Oop. Okay, so I got 1, 2, 3, 4, 5, 6, 7, 8. 8 a.m., 9:43 a.m., 11:19, 12:47, 2 p.m., 3:45, 7, and 9:45. Okay, let's change up these values. This is going to be 9:43. This is going to be 19 and 11. This is going to be 12 and 47. This is going to be 2 and 0. This is going to be 3. No, sorry, this is going to be 2 plus 12. This is going to be 12. 0 plus 12. Just to kind of distinguish these PM ones. 12 plus 3 plus 12. And then here it'd be 8 plus 12. And then here 9. So let's quickly change these. 45. It's gonna be 0, 0. This is gonna be 7 though. 3, 45. Oh, whoops, sorry. So 9, 45, 0, 0, 45. For 3, and this is gonna be 7. 2, 0, 0, 12, 0, 47, 19, 43, 0. Okay, so let's go through these. 8, 9, 11, 12, 2, 3, 7, 9. Great. 45, 0, 45, 0, 47, 19, 43, 0. Perfect. Okay, so those define those values. So now what we can do is get rid of this here and just do if 8 a.m. less than 9:43 a.m., then do this. Now what we'll do is we'll do a similar concept here, but for these guys. Okay. So this one's going to be for 9:43. So this is going to be the 9:43 a.m. and the 11:19 a.m. 9:43 a.m. and 11:19 a.m. Next one, 11:19 a.m. So we're going to do the 11:19 a.m. and the 12:47 p.m. So next one's going to be 12:47 p.m. here. Right, and then the 12:47 p.m. goes to the 2 p.m. 2 p.m. This will be 11:19 a.m. Sorry, this isn't 11:19. This is 11:52. Gosh, this one's like kind of annoying. Python hash table is so much easier. Okay, 8 to 10:16. 9:43 to 11:52. 11:19 to 1:31. Right? So 12:17 p.m. And this would be p.m. here. Right? Arriving at 3 p.m. So 12, and then this would be 2 p.m. Okay, great. So the next one would be 2 p.m. 2 p.m. and then 3:45, and then it would arrive at 4:08 p.m. I'm gonna get rid of these guys just so I don't have to keep changing. Okay, now this would be 3:45 p.m. and then it would go to 7 p.m. Well, oh wait, we want the thing is, I don't think this is gonna work either, because I think we need the absolute value, right? Because we need to do the absolute value of the times, because if you have the time goes over the current time, the setting in C. No, for absolute value. does nothing. So I guess there is an absolute value function here that we can just use. I don't know if it was included in the standard I/O, but we'll find out. That's for sure. So 2 p.m. goes to 4:08. Oh, hold on. So we have 2 p.m. 3:45 goes to 3:45 p.m. and 5:55. Then this one is 7 p.m. and 9:45 p.m. So 7th row goes to 9:20 though. And then this one is 9:45 p.m. So then I guess else it would be your closest to I guess you don't even need this statement. This would be 9:45 p.m. to 11:58, the 8 p.m. Now this would be 9:45, 7 p.m. Okay, so we need to make sure though that the user doesn't enter, so if so the maximum time you can have what is 24:00, no 23:99, no the maximum value you can have in 24-hour time is 24 hours, right? We can have 24 hours and 59 minutes, which will reset you back to 1, right? So it'd be 24:59. So if time in minutes, well, I guess actually we want to put this here. So if hours is greater than 24, or minutes is greater than 60, or minutes is less than 0, which I guess it can't be. Right, so has to be within these ranges, right? So it'd be like 0 is less than minutes, which we would want it to be less than or equal to minutes, which is less than or and minutes less than or equal to 59 minutes, right? So then here we would have to say hour, or so you can't have 0 hours, so it'd be 1 less than or equal to hours, which is in and hours less than or equal to the maximum number of hours, which is 24. So if either one of these is false, then you're going to printf invalid 24 hour time. And then you're going to return 1 here. Let's see if this works. Okay, so we have to include, which we haven't learned about it yet, the standard library .h. $13.15. Dang it. Is greater than or equal to 1. An hour is less than or equal to 24. Oh, this is for valid times. Can we just do this? No. Yeah. Okay, so this is for valid times, right? So we would want to I guess we would stick in I mean, actually, I don't really want to. So to make this for invalid times, we would obviously want to, if hours is outside of these rounds. So is there a quick way that we can make it so that it does the opposite of these? Okay, so this is saying that the hours has to be within this range and the minutes has to be within this range. And we'll get an invalid time always if that's the case, which is not what we want. So we need to put a, if hour is, hours is less than 1, right? 1. Or hours is greater than 24. So either or of those have to be true. So then if minutes is less than 0, or minutes is greater than 59, valid time there. 13:15. Okay, so this gets us time in minutes here. And now we're printing out all of these because they're not else ifs, right? We just need to convert these to else ifs so that they have that logic conditional to break out if any of these are true within the chain. And we do 13:15. Closest departure time is 12:17, which I don't think it's supposed to say 12:17. I think it's supposed to say 12:47. Nice. Okay, I think that works. Let's do 7:45 a.m. Right, 8 a.m. is the closest time. Cool. Okay, let's get rid of that line. We don't need it. Okay, 24-hour time. Let's do like 14:25. Right, this should just go to the 2 p.m. 2 p.m. Perfect. All right, that is that one. That was kind of long, but wasn't that difficult. But it's just kind of long and annoying, right? But I think that covers all of our cases. Now the thing is we had to include the standard library when we actually haven't learned about absolute value yet. So I'm going to take this. Let's go here and say I am solving a flight time mapping for the nearest input 24-hour time. I do not have access to loop yet, or even learned about the standard library with absolute value. So I think I could be cheating here. Let's discuss alts. It's a perfect moment to think about how to solve the same problem with only tools you've learned so far. Simple variables, if statements, no loops, no arrays, no absolute value, or no libraries. There are two big constraints you want to avoid. You haven't learned loops or arrays, and you haven't learned absolute value. You can't solve the closest time problem cleanly with just the basic stuff, but you can solve still this, right? Compare raw differences manually. If the time is less than or equal to the midpoint between two departures, pick the earliest one, pick the later one. Because the closest between two times always splits at the midpoint. Okay, so if you find the midpoint between two times, 8 a.m. and 9:43 a.m., right, which is 8:51 a.m. or 531 minutes. If it's less than or equal to this one, do that. Else, pick this one. Hold on. Well, in the example it gave, it allowed for the negative time, meaning to go back in time for that flight. It just is the absolute nearest flight given the time in either positive or negative time. So not the nearest flight that hasn't left yet. So you're solving the version where the closest flight can be before or after the entered time. So the user enters 10 o'clock, the closest might be the past flight at 9:43. you can still implement absolute value logic manually. So int diff, you take the difference between the numbers. If the difference is less than 0, then you multiply. Oh, this is just the result. If diff less than 0, then diff equals to negative diff. If diff is less than 0, so the difference between the value. Okay, so let me go ahead, instead of including the standard library here for the absolute value, right? Should I just write my own? Hey, how's it going, Starve? Thanks for coming in. Thanks so much, Juanek. Thank you so much. Hey, Ray. How's it going, everybody? Okay, so diff is less than 0. Diff equals to negative diff. What does this mean? I'm struggling with this guy. So it's taking the difference between the two values. So if the difference between the two values is negative, so time in minutes minus 8 a.m. Okay. Now, if that difference between those is negative, meaning that the time in minutes is after 8 a.m., then you're just setting the diff to be negative, which it already is. Why are you setting diff? Not saying you're changing a negative into a positive. Oh! If it's less than negative, then I'm making a negative times the negative diff. Got you. Okay, so let's do this then. Int so let's get rid of this then. We'll say if we have to create an absolute value here, right? So they do the difference between our time and these values. So you'd say like time in minutes less than the time in minutes less than the 8 o'clock time, right? This would say if time in minutes, right? Could I really get crazy with this? If time in minutes here is less than 0, then if time in minutes, if the difference between these values is less than 0, then we're going to do negative well, it would be this guy here, right? Which is kind of crazy. Now we're getting, it's like the syntax looks awful here. Right. Else it'd just be time in minutes. Or else it'd just be the diff. Right. Yeah, because it's still calling absolute value here. So let's see if that still works despite despite the syntax looking awful. Expected. Yeah, it looks terrible. Okay, so I'm not even gonna mess with that. Should we just make our own? Yeah, so that's probably what we'll have to do here. Let's go. Let's go int. Hey, thank you so much for the follow. I appreciate you. So int. Hey, thanks Carson for the sub on YouTube. Thank you. You're awesome. So let's define an absolute value function, which will take in a value of a, which is an int, and a value of b, which is it's int a and int b. And then what we're going to do is, I know we haven't even learned about functions themselves too, so are like creating our own yet in the book. So this is kind of cheating as well, but it's whatever. Return a less than b hold on, we'll say if a less than b, right? With the ternary operator, do you even need to do the if statement? A less than b, then a less than b, then no, it'd be the difference between the values, right? So int diff is equal to a less than b. If so diff less than 0, then we're going to do negative diff, else diff. Return this statement here. Oh. Absolute value just takes in a value of int a, right? And just says if return if a less than 0, return diff this, right? So then what you do is you have the differences given here, and you take the absolute value of it. And I did diff here. Okay, so, a. Closest departure time is 12:47 p.m. So that still works now. Let's say 17:47. Closest departure time is 7 p.m. There we go. So we'll just kind of define it like that. Okay, so I think that is this problem. Holy crap, that one was a little bit longer than I thought it was gonna be. Just like, it's not, honestly wasn't that hard, it's just a little bit of it's just tedious, just a lot of tedious stuff. But, I mean, we went a little overkill with like the error checking and, you know, input handling. I'm sure that's not like super required, right? But it's pretty, you know, customary. It's like the right way to do things, right? Yeah, Lamont, we got that. Yeah, thanks so much, dude. Sorry, I was thinking of it. We were already doing the division here, or the subtraction here. Yeah, so it'll just take in a single value and return the absolute value of it. If it's negative, return it, return the negative times the negative value, and then we get this. So now we implement our own absolute value function without absolutely having to use the standard library, which we haven't learned yet in the book. So proud of that. Cool. That was number 8 here. Line 6 needs a semicolon. Oh, here, yeah, so my bad. Again, so also I think we are cheating technically too, because we haven't learned about made my own. This is exactly how I'm supposed to solve it. Oh, TJ. ChatGPT disagrees with you here. Not harmful, but C treats this as a function definition followed by an empty statement. No semicolon after the brace of a function. My checks are off by 1. What? Why are my checks off by 1? You currently reject hour 0. I reject hour 0, yes. Hour 0 is not allowed. Hour 24, though, is not being rejected. I'm greater than hour 24. Sky, come on. Why is this wrong? My hour can't be greater than 24, and it can't be less than 1. "24-hour time" is technically valid. Hours can only be 1 to 24. Included 24, right? Oh, okay. So I'm just thinking about my bad. So you reset. I just never use military time or whatever, 24-hour time. I'm an American over here. Sorry. I was wrong on my interpretation. You only go up to hour 23:59, and then hour 24 is. Oh, hour 24 is 0. Oh. Hour 24 is 0. Oh, gotcha. I thought it resets at 1, like at noon. My bad. Okay. Whoops. So this is actually 0 and 23. Right. Okay. I thought it does it. Okay, my bad. My bad. I thought it was like at noon, 12 to 1. So 12 a.m. to 0 is 0, 0, and 12 p.m. is 12. Whereas 1 p.m. we go to 1. Gotcha. All right, a little bit of a quirk. Hey, what's going on, Brandon? Appreciate you coming in tonight. Let's keep going with the tunes here. Man, we spent an hour on that one problem. Holy crap, dude, I suck so bad. No way I'm passing a C interview at all. Okay, let's move on. Okay, here we go. Write a program that prompts the user to enter 2 dates and indicates which date comes earlier on the calendar. Okay, so let's go include the standard io.h. Let's go to int main void. Let's open this up. So we're going to printf and go enter first date, month, day, year, like so. We're going to call a scanf function to read in the data of this month, day, and year. We're going to save this in first month, first day, first year, and we just need to give some ampersands in front of these bad boys. Boom, boom. All right, let's dupe this up. Let's call enter second date here, and we're gonna do second month, second day, and second year. Let's go ahead and define these variables, or declare them. First month, first day, first year, second month, second day, second year. Okay. So that'll save those values. So right off the jump, you would first want to check the years, then probably check the month, and then probably check the day, right? So if second year is greater than, sorry, if second year is less than, is greater than, or sorry, let's just do this. If first year is less than the second year, right? Or the first day, sorry, first month is less than the second month, or the first day is less than so if the first year is less than the second year, then the second date comes first. Or then the first date comes first. Right? If that is not true, then it'll immediately go to our else case. What happens if they're the same? Then it'll move to this case and check. Now, if this case becomes, so if they're the same or second year, okay, got you. So if first day is less than the second day, then what we're gonna do is call printf and say first, or we'll go here, %d, first month, first day, first year goes there, and it says is earlier than, and then we do %d, and we're going to insert here second month, second day, second year, right? Now elif, I guess the else statement would just be if any of these are not true, right? Then you print out the inverse. So it hits this here too. So we don't have a case for when they're the same date, right? Which we could add here. So let's go ahead and make some minimum fields here. So not minimum fields, but precision. So to 2 digits displayed. So if we go 01, 25, 25, 01, 30, 19. Oh, whoops, I'm trolling. Oh, 01, 30, 25, 01, 30, 19. No way. First year wasn't. Oh, got you. Okay, so just because the year, if the year isn't true, right, we don't want to check anything else. Because the year is actually what so if the year is less than, it automatically happens, right? Now what happens if the years are the same? Right? So would we need either and no. So if the years are the same, right, this will report to false. Right? Meaning that we need to further, meaning that a decision can be made right away. Right? It can kind of short circuit here. Okay? A decision can be made right away if the years are different. Okay. Now, if the years are different, then this will be made. So we need an or here. Okay. So if the years are not the same, or if the year... So we might need a less than or equal to here, right? And this would be an and, because we want this, so if this is false, meaning that the second year is actually less than the first year, then this will not happen, right? And so it'll automatically go down to this one. So if the first year is less than or equal to, we're going to need to further evaluate, right? And the first of the month, the first month is, well, what if the months are the same? So less than or equal to the second day. Oh, wait, what am I doing here? Why am I comparing days and months here? This should say month. Whoops. So if the first month is less than or equal to the second month, okay, so let's back up. If the first year given, which is in this case is 08, so 2008. So the first year is actually greater than the second year. So that's would default to here, because the first year in this case, this becomes false. This and requires both of them to be non-zero, so this short circuits and goes to here. So then, let's just say it's flipped 07 and 08. So the first year is 07, which is less than second year. So what if we did this? What if we did first year less than, right? We did this evaluation. No, it would have to be less than or equal, right? Because we want the years to be equal, and then we can further evaluate within here. So if the first year is less than or equal to the second year, so let's say it's the first year is 07, the second year is 08, then this evaluates to true. So this is 1, and we need this then to evaluate to true. So if the first of the month is either less than or equal to the second of the month, then that evaluates to true. Now if the first day is less than or equal to, is less than the second day, then you have a match, less than or equal to the second day. Less than the second day, because if it's equal to the second, it's the same day. So then what we could do is we could go like this. Let's keep it like this. We'll do another evaluation. Say if first day is equal to the second day, right? Then we're going to printf saying that they're equal. Okay. Else, right, else we're going to print this here. So if the first year is less than or equal to the second year, and the first of the month is less than or equal to the second month, meaning that the first year is either we are either on the same exact year with the same exact month, and we need to evaluate on the day, or we've already found a point where, well, actually, if this hits and past this case, if the years are different but the days are equal, then this is actually wrong too. Ah, crap. Right? So then how can we say, so both of these have to be true for it to move forward. Trying to challenge myself and keep it within just one if else if possible. Trying to see if we can work out the logic that way. So the first year is less than or equal to the second year. We're going to enter it into this. So in the case of 0808, that's true. And so on. Zero. And those two, so that'll be all the first day. This has to be in as well. First day is less than the second day. You do this. Else you do this at any point in time. Let's do 01, 30, 25. Okay, that works. So because the days are the same, you're getting hit with that else block, right? Because the days are the same, you're getting hit with that else block. Because that's not true. So if I say or first days less than, well, that means that if that's true, that goes to 1. That evaluates to 1. For if the months are the same. And we say or, that'll be still true for if the second day is greater. If the second day is greater, it'll still be true. if we do or, which isn't what we want. Let's try this. Let's say first before second. Going to go include the standard bool .h header file. Let's set this equal to a bool, and let's be equal to true here. Okay. So if first year, if the first year is less than the second year, right? Then we know that if the first year is less than the second year, or no, so you don't want to do or. So if the first year is less than the second year, then we know automatically that the first year is comes earlier, right? So you can just immediately set first before second remains there, right? Else so it stays true. Else if so if the first year is less than the second year, then the first year we automatically know is there. So if we automatically know that that's the case, but what happens if they're the same? That's the case I'm trying to figure out here. So if the first year is less than the second year, then we automatically know right then and there that the first year comes before the second year, or the second date, right? So else if then the first year, right, is equal to the second year, right? And first month less than the second month, right? Then that would still happen, right? So the first year is less than the second year, we automatically know. If the first year is equal to the second year, and the first month is less than the second month, then the first before second is true. Else if first year is equal to the second year, the first year is equal to the second year, and the first month is equal to the second month. Right. And first day less than the second day, then first before second still remains true. Right. So if the first year is before the second year, then we know that the first before second is true automatically. So what happens if then they're equal? Well, we then check if the first of the month then is less than the second month. If it is, then we true. So else if the first year and the first month is equal, the years are equal and the months are equal, and the day is less than the second day, then that becomes true. Else if the days are equal, I guess then we have the else statement here. It would just say first before second equals to false. It's cold. I need to get a jacket. Hold up. Grab my Do you see Google's new SEMA 2? No, I did not. Sorry. What's going on? Okay. So I don't think that this would work though. Okay, we need to actually do something though. If first before second if first before second, we're gonna print, I'll just do this first before second. I'll format it later. Second before first. I don't think it's gonna work. Try one. Second before first. First before second. first before second on the month. Okay, so is this right then? Am I having any edge cases I'm missing? So if the years are automatically, then no. Let's just do bool equal dates. Right. So equal dates equals false. So if we evaluate this, we do an else if here and say first day and second day are equal to each other, then first before second becomes false. And equal dates becomes true. Right? And so if first before second, then first before second. And then we would say else if equal dates, we would print equal dates. We would say else so if first before second, we know that's false. So equal dates. So second before first. Okay, let's try to go through and clean this up here. Okay. So we are saying we're first determining if the first before second is equal to true. So right off the bat, let's set it equal to false. And let's try to then set it to true if that's the case. So let's think. So if the first year is less than the second year, first before second becomes true. Also. So that the first year is less than the second year, and or no, we want to say or there. So this sets it to true as well. So we could say, let's say or here and take this condition, put it here. That'll remove this else if. Right? Now I guess we can do the same thing for this guy here. first year equal to, but we've already checked first year equal to this in this statement here. But that evaluated to false, and we don't know where it evaluated to false, right? So if we take this entire statement here, do an OR, put it there, remove this guy. Now if they're all equal to another, we set this there. Okay, so now let's do our formatting, I guess. So let's do the %d slash %d slash %d slash, okay, that is earlier than right, and then we're going to insert first month, first day, first year, second month, second day, second year. Cool. And then I'll take this here. Second month, second day, second year, first month, first day, first year. No, I guess we'll take this. Paste it here. Or wait, what just happened? Second month, second day, second year, first month, first day, first year. And then I guess we'll take this one and do R equal to is equal to. Okay, so that's what I got here. So we have a first before second Boolean and a equal dates Boolean flag. If we hit a condition where the year is either less than, the first year is less than the second year, which short circuits to first years before second. Well, if the years are equal and the months then differ, then then it becomes, and then if those two are equal and the days differ, then there, right? Else if they're all equal to one another, then there. Else, then we know that the second date comes first. So if we compile this, expected expression on line 24 at the else here. Expected expression on the else. Oh. It's because we have multiple things going on, I think, right? that's a single print statement actually. Yeah. 01, 01, 25, 01, 01, 24. 0101 is earlier. Okay, let's add in our decimals that we want to, our formatters. Boom, 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 boom. Okay. Let's try it out here. 01, 01, 25. 01, 01, 24. Perfect. 01, 24, 25. 01, 23, 25. Nice. 01, 01, 25. 02, 01, 24, 5. Nice. Okay. Now I just need to add some backslash ands. Always forget those. We'll get caught up on some chats here. Cool. All right. Oh, that's probably a good idea, Andre. That's a good idea too. Convert the dates to a total number, and then just do comparisons based off of the number itself. That's actually a really a neat way of doing it. That's smart as heck. That's really smart, right? That's really smart, dude. That's actually a really smart way to do it, because if you just sum the numbers. Maybe if you give the years a certain magnitude, right, that's greater than the other ones. Right, because they don't all carry the same weight. So this number would be technically smaller than this number, even though this number here has more weight than this number. So you would have to make sure that the yearly weights are more than like the weights of the individuals. That's smart. Okay, let's get some feedback here. Okay, this one was annoying, but I think I got it, but my logic probably could be polished up. Your program works, but the logic can definitely be polished. This works, but there's some redundancy, right? So this is an alternative to how we could have done things. You could structure it like this. So if the first year is less than the second year, or first month equals the first year, right? Or, okay, so this is currently what we already have. Oh, it just got rid of the bool variables. And then this is the example that Honor, he just told us right here. We can simple it down way further if we provided some magnitudes to the years, some magnitudes to the months that are less than the magnitudes of the years, and then just the minimal magnitude for the days, and then do an evaluation of the actual numbers. That's actually a really smart way of doing it. That's actually really smart, just doing magnitude-based summation of the numbers themselves. My mic stopped working for some reason. That's actually really smart, doing magnitude-based summation on the dates. You don't get a natural order of things. You can just do this, just comparing the actual numbers. Dang. Shoot. Okay, cool. Well, this one got some good practice with the logic gating, so it's okay. All right, 2 more here. Let's keep pushing. Let me catch up on some more chats here real quick. All right, later, Radical. Okay. Cool. Yeah, what would you do for the edge cases of like 2000? No, mine. Well, mine. How to fix it? Use 4-digit dates, right? Okay. Well, kind of a bummer, but that's interesting. So we'll have to actually, let's just do it the other way then, which is kind of a waste of time that we've wasted all there, but it's all right. We were learning. Got some good practice with those logic gating, which is good. So let's go ahead and do this instead. Let's do first is equal total is equal to what happens if you just take the numbers themselves? Right, so you do 90 times 90 is definitely higher. It's 2000, so you do the year. How does it handle the times 10,000? But you enter in years in 2-letter. But if it's like 90 versus 00 in the 2, Okay, so it's interesting. We have some edge cases and stuff that's like that weren't given in the examples, right? That we thought of for like 90 versus 2000, like 1990 versus 2000. Where if we did it this way. So what we need to do is, well, they don't specify the year. So if they put 90, it could be 2090, it could be, it could be 1990, it could be 1890. It's kind of flawed in the actual question. Right? Yeah, Honor says 2-digit years will always be broken. Right? It's kind of a flaw in the question if it's only asking in these examples for mid 2000 years. Is it a flaw in the question then? Where 2-digit years will always have issues because you do not know 90 being 1990 or 1890 or 2090, etc. You've hit the subtle flaw in the question. If the prompt asks for 2-digit years and it's inherently ambiguous century information, 90 could be 1890, 1990, even 2090. 00 could be these. Without extra context rules, you cannot reliably compare 2 digits across centuries. That means your program will only work correctly for 2-digit years are in the same century, or if you adopt a rule interpreting them. Okay, so let's make a note here and say we'll make a note here, we'll say there is a flaw in the question. The code only works for dates within the same century. We need additional context from the user for 4-digit years in order to compare across multiple centuries. Right. Okay. I don't even think I need this. Let's take this, put it right here, get rid of this. Wait, what the heck did I just do? Yeah, so we'll take this, put it here. We'll take this, put it here. Take this, put it here. Remove this, remove this. Nice. 2-digit years are fine for exercises for a single century. If you want a tiny tweak. Okay. Cool. Because the problem, it's pretty, it's a vague problem. We'll just leave it at that. And yeah, cool. I'll leave it at that. All right, let's keep going here. Next one. Using the switch statement, write a program that converts a numerical grade into a letter grade. Enter the grade here. Okay, this is pretty easy. Include the standard io.h header file. We have an int main function, which takes in no parameters. All right, we're going to call printf and enter numerical grade. And then we're going to call scanf to read in the data the user enters, which will be in integer form. Now, I'm assuming this is an integer because it gives whole numbers. Okay, so the switch case statements, you can't use so the constant expression. I don't think we can insert variables into the constant expression. Right, so let me go back up to the switch case statement really quickly here. Is much like an ordinary expression except that it can't contain variables or function calls. Thus 5 is a constant expression, 5 plus 10 is a constant expression, but n plus 10 isn't a constant expression. Unless n is a macro that represents a constant, the constant expression in a case label must evaluate to an integer. Okay. So if that's the case, I guess we'll read it into 2 decimals, 2 digits. We'll save it as the tens and the ones place. Let's go up to our top of our function here, go int tens and ones. And then we have switch. Yeah, so switch, and then we put into here the variable that we're going to be evaluating. Right, so be tens. Yeah. So then we'll do tens multiply equal by 10. And then we will do a switch case statement here for case of so our case is going to be $90 less than or equal to tens and tens less than or equal to 100, right? And then you open this up, or you just do a colon for what we want to do in this case is what? We want to okay, so this is going to printf. a backslash n, right? Okay, so content statements after that, printf and then break. Okay, so then we do a case here. So I think that's it. 80, 89, 79, 60, 0 to 59. 80 to 89. 70 to 79. 60 to 69. And then you have this is going to be A, B, C, D, F. Case of 0 to 59, F. Then we have a default, which will be default colon printf. Then we're going to do never did. Okay. So I'll print invalid grade. Okay, let's open this up. 10. Expected after the break. Okay, whoops. Five errors, especially as non-integer constant. Oh, because you can't use the variable. Ah, that's right. We can't insert the variable. Huh. Just on like things of cases, not for like case ranges. You're following scale. You just switched to that parameter. So I can't do an expression. Or a logical comparison within the case statement. Or the case expression, right? Right. So we've converted tens, which is a value. A range. I think we can do a case range. I don't want to do like just values. Like that would suck. Like, is it really wanting me to do like values? Like 90. Like case 100. Case. I'm not about to write out 100 values. No way. Like this. Like, no way. Oh, we're just doing the... Oh, I'm so dumb. We're just doing the comparison on the converted 10. So the case is... So if you got a... I think I figured it out. Hold up. 84. We dropped the 0. We just look at the 8. We got 100. Right, if we got a 100, that's the thing though, is the 100 is a little bit different. So the thing is though, is you're gonna get so you split it into two, it's not going to do that. It's going to receive the first one, and then nothing's going to be in the second one. So we're going to have to receive a single value here. All right, this is going to be grade. Right? Grade goes in there. We then are going to take grade and we need to so if I modulo this value by 10, I'll get a full, I'll get no, 4 back, which is the value of the ones place. So we do 100 mod divided by this, that'd be, right? So we need to break the grade down. So we need to use the modulo operator to get off values, right? Until we need to get off the ones place value. So we need to do a single mod operation. Now we have to do that by, okay, so taking 84, or the value, and modding it by no, I'm so dumb. Let's see, if we do for mod 100, that gives me back 84. Now if I do 100 mod 84, I take back 16. It's a remainder, yeah, between that. This is not what we want. So we just want to get the grade off of the end here. My brain's starting to slow down here. We've been going for over 2 hours. Okay, so if I take 84 and mod it by 10, right? 10 goes into 84 8 times with a remainder of 4 left over, right? Yeah. Okay, so if we take remainder is equal to our grade modulo by 10. Then we take our grade less equals by the remainder. So if we had a grade of 100 and modulo that by 10, we get 0. That'll give us a grade of 100. So the case for grade, case of 100, case 90 is going to be A. Case of 80 is going to be B. Case of 70 it's going to be C. Case of 60, it's going to be D. In case of well, I guess default be F. Right. So in this case, would be our default case for F right? And then we would have here though, if grade, if 0, or if grade, okay. Oh, sorry. If the grade is less than 0, or grade greater than 100, then we're going to printf error invalid grade. Right? And then we're going to return 1 here. So then we're going to get a remainder. Okay, so if I run this cheese, warning, format specifies int star, but the argument has type int. Oh, remainder. Int run. A. F. Error invalid grade. 77 C. 62 D. 89 B. Cool, I think that works. What do you guys think? All right. Let's get some feedback on this one. You get the ones digit subtracted from grade. Then the switch takes the tens digit rounded down to the nearest 10. So is to divide it by 10. I'll give you a value. Oh, wow. That's way easier. Wow, I'm so dumb, dude. Like, why do I make things a lot harder on myself? I do that often. So you can just divide and do integer division down, which will automatically divide it down to a one singular value. So this does work, but we could do it even better by doing this. Just grade equals to grade divided by 10. So this will take like 89 and floor it down to 8. Or take 99 and floor it down to 9. Or 77 and floor it down to 7. And then we just have the cases of 10, 9, 8, 7, 6. Right? Nice. Okay, cool. Okay, let's go ahead and do the last one here. Last one. Leave a like on the stream if you guys are enjoying it so far, enjoying the C practice problems. Appreciate you guys being here. Takara says you could also do the switch grade over 10 for a cleaner code. Oh, that's a good idea as well. Grade by 10. That's a good idea. So we can just do this guy here, actually. Let's go up and compile that one. Nice. Cool. All right, last one here. DevGod says, well, what's going on, DevGod? Sorry, I was on the wrong chat here. I didn't see the Twitch chat. My bad. 800 pages of C programming. This is a free open source book. Yeah, it's a free book online. You can find it online if you just look up C programming, a modern approach. It's over 800 pages with practice problems and practice exercises at the end of every chapter. And so we've been getting a lot of great, probably over close to almost 50 practice problems and exercises combined so far in these first 5 chapters. So a lot of hands-on practice with these introductory functions and methods of printf, scanf, and whatnot. And we're going to get into loops in chapter 6 next. Man, I got the hiccups. Ah. Okay. Appreciate everybody being here and hanging out with me today. Let me know what you guys are working on and studying. Number 11. Write a program that asks the user for 2-digit number, then prints the English word for the number. Break the number into 2 digits. Use the switch statement to print the word for the first, and then use the second switch statement. Okay. 11 and 19 require special. Okay, so we have include the standard io.h header file. We have int main function that will be void for any parameters or arguments. We're gonna have a printf. We're gonna have an int. And we're gonna have num. We're gonna have a printf. It's gonna take in enter a 2-digit number, like such. And then we're going to call scanf, and this is going to be for the number, and we're going to save this in num. Okay. If num, if 11 less than or equal to num, and num less than or equal to 19, then we know we're going to print f. We're going to have a switch for num. Case of 11, we're going to call printf and say 11, and then break. Ooh. We're going to copy up this 11, 12, 13, 14, 15, 16, 17, 18, 19, 11, 12, 13, 14, 15, 16, 17, 18, 19, it's 11, 12, 13, 14, Is it 15? Is it 15? Like that. 15. No, 15. 15. 16. 17. 18. 19. Is it N-I-N or is it? No, it's gotta be N-I-N-T-E-N. 18. Okay, so that'll handle the teen values. Print the word for the first digit. So enter a 2-digit number. You divide it by 10. You get the first value. So we'll say match, or so we'll say, I'm sorry, it's switch. We're going to say the num. We're going to say case. This is going to be num divided by 10. So this is the ones place. Yeah, so this gives you the tens place. So num divided by 10, case of 9, printf 90, right? And then we're going to call a break statement here as well. Ooh. And then we'll go up and duplicate these 8, 7, 6, 5, 4, 3, 2. Okay, so this is 80, 70, 60, 50, 40, 30, 2 is 20, okay. So maybe actually we'll get rid of this. So in the case of a 1, if can I take okay, hold on. So let's just think here. So we got the num divided by 10, 90, 80, 70, 60, 50, 40, 30, 20. And then we're going to find the remainder. So rem is equal to our num modulo by 10. Right. Hey, how's it going, Odin? Appreciate you for coming in. right? So then we go switch rem, and this is going to be a case of 9 goes print. Okay, so we'll basically copy this over here. But this is for num mod 10. Gives me case 9 would be 9, 8, 7, 6, 5, 4, 3, 2, and 1. Right? So in the case of a 1 here for in the tens place, it's either 19 or a 10. We're going to say if basically you're going to take this statement up here the switch num statement here, and put it here. Right? So in the case of 1, it's 11, 12, 13, 14, 15, 16, 17, 18, 19. Well, I don't think that this is going to work. So we find the first value, right? We find the first value. We did that. We say, okay, it's 90. And then, in the case of 1, if it's this, you print 11. And then I think right here you would return 0. No, here. Print 0. And then here, if we get this, you do print f to a hyphen here. So now if we run this on 11, $55. Okay, now let me make these lowercase because that's what it has in the example. It's not that big of a deal, but just to be consistent. 4, 5, 6, 7, 8, 9, 9, 9, 8, 17, 16, 15, 14, 13, 12, 11, 20, 9, 8, 7, 6, 5, 4, 3, 2, okay. So now if we run this, 89, 89, 17, 11, 96. Backslash n, backslash n, backslash n. Okay, cool. I think that works. As your code is trying to convert two-digit number in English, which are a few things to notice and fix to make things fully correct. Oh, whoops, 40 is with O. Add a case for 10. Oh, that's right. Oh. So let's remove this. We want to do a hyphen on these guys here. Okay, cool. I think that works. Oh. Okay, so the fix would be two-digit number, return 1 if you're not in this range, which we know this is an error check, so I'll just take that over. I'm fine with that. Right. Now you have int is 10s and 1s here. So if 10s, so you do int 10s, which is equal to num divided by 10. Then you have int 1s, which is equal to num mod 10, right? Then you have this switch, so if if 10s is equal to 1, we're going to open up this. Do a switch on the num. We have case. These guys. Right. So that would to I kind of like how it formats that. It's pretty annoying how I did it. Break. 11, break. Oh gosh, this is annoying. Okay, I'm done with this. Okay, so I'm getting annoyed. Break here. We break here. Break here. 14. 15. This is annoying. 17 we break. 18 we break. After we do 18, break. Okay. And then you'd return 0 after that. And then that would end our method here. Then we do the switch for the 10 statement. All right, so that'd be switch 10s, which would open up. Case 1. Okay, just do it, Mike. Tedious formatting is really annoying my brain. Case 6, 7. Break. Okay, so I'd handle the 10 statement then. Now to do the ones, I'm kind of lost. Okay, so so it's going to run this. It's going to print either if 10s is equal to 1, then it's going to either print all these and return. Now if we're going to do a case of 10s, right? We're going to evaluate the 10s and print out the appropriate value for the 10s. Now if one's greater than 0, right, or not equal to 0, which it will be, right? If it's greater than 0, we need to figure out ones to do. So this is where we do so you do the hyphen here, right? And then you would do switch for the ones. Open this up for case 9, printf for quote 9 backslash n. And then you go break, right? Yeah, so we would do this for all the values. It would follow 8, 7, 6, 5, 4, 3, 2, 1. 8, 7, 6, 5, 4, 3, 2, 1. 8, 7, 6, 5, 4, 3, 2, 1. So this is going to print out and return if it is there. Now if it's 99, we already are printing the backslash n, so why is it printing a backslash n? Oh, because you don't know. Got you. On this else case here. So it would be like else here, printf, just a backslash n for like the 40, 60 by itself. And then this would return 0 at the end here. Like so. So if we try that, 55. Now if we try 10, try 5, not a valid 2-digit number, perfect. Let's try 80 flat, now you 80 backslash n. Or /n, this is not right. Oh, backslash. Oh. Okay, so if we compile this and do 89, nice. 45, nice. 100, not a 2-digit number. 62, nice. Okay, so that is working appropriately. So what we had to do was isolate the tens digit and the ones digit using some math by just dividing integer division by the magnitude that we're looking for of the digit size, and modulo by that digit size as well to pull off that first number, or that second number, or ones place. We then match the tens if the tens is equal to 1 for any teen values between 10 and 19, right? If tens, and then we do a switch statement determining whether the 10 is 90 through 20 through 90, and then we match it with the ones place of 1 through 9. And then we have a printf for a backslash n here in case the ones is 0, right? Then it'll just print 20 backslash n. Cool. Let's take this. Let's see what you get. Cool. Hey Tim, last problem before we go online. No, I never was into poker or nothing like that. I just play the options. I just play stocks. That's my form of gambling. Alright, cool. Those ones were lengthy, dude. We took 3 hours just to do those 3 problems. I mean, they weren't like hard. They just were like, they were almost like 50, 60 lines of code, each one themselves, right? So We wrote over like, you know, good 200, 300, 200 lines of code today almost. So, I mean, not bad. Cool. So those were those 4 problems. Let's go ahead and push this up now. We want to do a new terminal. Finish chapter 5 programming. Chapter 5 completed. What? Okay. Cool. Writing commit message is the hardest part. I think I think that does this escape in commit messages. Yeah. Okay. Cool. All right, that was a lot. That was Chapter 5, Programming Projects 1 through 11. If you guys would like access to these programming projects and the answers that I've come up with, I'm not saying that they're the correct ones, but they are somewhat, they're correct for the problems, but there's probably multiple ways to do it, obviously. So just take that with a grain of salt. But my answers and solutions are posted onto my GitHub right now, linked down below. I just push them up for all of the up to Chapter 5 exercises, notes, and programming practice problems. So we will be ready to tackle loops next time in Chapter 6. So super excited to continue on with Chapter 6 next time and finally get into loops to where we can have stuff happen for us automatically and we can definitely write less and less code. Yes. We've been kind of restricted up to this point using kind of a lot of more brute force approaches through our problems because we haven't had access to loops or char stars or arrays to be able to loop over, these objects. So we've kind of just been having to brute force line by line through variables and perform kind of repeated actions on our own here. So I appreciate you guys being here. I don't have any commands on Puffer. Sorry, dude. It's probably in my Twitch bio or my YouTube description here. So I apologize. I'm not that fancy of a streamer. I don't have a bot set up or anything like that. I need to figure that out maybe one of these days, but it's not like that crazy. Anyhow, I appreciate you guys being here and joining me for today. Thank you guys so much for hanging out with me. This was C Programming: A Modern Approach, Chapter 5, Programming Projects. We did projects number 8 through 11. So super awesome. We were able to wrap up those for today. I'm excited to get into Chapter 6 next time. How long is Chapter 6? So Chapter 6 starts on page 99. $120. So it's about 21 pages. It's pretty long. We'll definitely have to read it next time. I was thinking maybe we start it, but probably not today. All right, you guys. Thank you guys so much for being here and joining me. What do you guys have any advice for? I find myself like spending 2 or 3 hours learning C. And which is great, we're learning and we're stimulating our mind and programming and learning a new programming language, which is awesome. But I really don't want to forget or kind of fade off of our Python knowledge. Now I know that Python, a lot of the stuff kind of translates from Python and C. It's just different, syntax and formatting or whatnot, because a lot of Python is written in C. But I don't want to forget a lot of like our Python methods and Python stuff. So I do want to continue on with maybe some more Python sessions as well. We do have our better options program that we need to finish for implementing our 3D view model of an options chain given some certain z parameter or amplitude statistic to track via volume or whatever we might choose for the amplitude statistic via that 3D model. So for example, if you guys are familiar with options contracts, you have a strike price and an expiration date. And so if we line up those strike prices against those expiration dates within an x-axis and a z-axis into the plane, and then we model on the y-axis or an amplitude characteristics of the option contract, we could get kind of this valley and peak model view of these options and identify visually which options, which strike price has like a steady increase or of amplitude for this characteristic or whatever, which could be kind of interesting. So I wanted to make sure we finish that. We're really close. We've already got all the data ready to go. We just need to actually plot it and figure out the 3D plotting surface in Matplotlib. So we've already gotten all of the data, the X, Y, and Z data extracted out. We just need to actually do it in our program. So thank you guys so much for being here and joining me for today. Really appreciate hanging out and being with me. We stream for 3 hours today, teaching ourselves computer science and programming from C Programming Chapter 5, C Programming: A Modern Approach, 2nd edition by K.N. King, Chapter 5. We'll be jumping into Chapter 6 probably tomorrow. So thank you guys so much for being here and hanging out with me for today. I will see you guys tomorrow. Thank you guys so much for hanging. Peace out.